the ruin lizard exhibits strangely a selective endogenous circadian rhythm.
In this episode of podcast, our guest is Jared Simonetti. He is a current student in Drew University, majoring in psychology and minoring in neuroscience. He's sharing his paper in comparative psychology, which is guided by Professor Drew D. Moore. His topic is influence of heat and light behavior in exotherms. We talk about the early studies in heat and light behavior, the interaction between temperature and behavior, role of melatonin in thermoregulation in Nocturnal African House Snakes, interaction between light and behavior, circadian rhythm involvement in temperature selection and light, and cyclic color change in behavior in the bearded dragon under different light conditions. All right, thank you, Jared. Thank you so much for joining my podcast.
Of course.
So your topic is influence of heat and light on behavior in exotherms, right?
Yes, it is.
Yeah, so let's start from the basic, yeah? So what is heat and light and how does it pair together?
So heat and light, as everyone knows,
Yep.
It's temperature, you got light, okay? And the reason why I chose those two as a facet to like explore in regards to exotherms is because exotherms, they don't have the ability to produce heat. And light is a major cue for where heat is.
Yeah, so what is exotherms?
So exotherms, those are everyone knows reptiles, amphibians, the naked mole rat. They're creatures that cannot produce heat. Reptiles are a specific one I investigated more so than other exotherms, mainly because there's more studies done on them specifically for light-guided and heat-guided behavior.
Right. So let's start from the early studies in heat and light behavior.
Yep.
So you have searched the behavior of the green iguana to heat and light exposure. So what is that study about?
So I chose specifically that study because it was one of the earlier studies on heat and light and behavior modulation in exotherms and reptiles. That one, I'm honest, that one I wasn't too much of a fan of. Not because of any like particular reason except for the fact it was old and they used some poor methods at parts. However, I chose specifically that one because it was early. It was new, at the time at least. That one was specifically looking into different iguanas at different ages and sizes. Those are like parts that are somewhat arbitrary. However, they were important for that study. And it basically gathered how their behavior was directed in a runway setup where they basically had a limited amount of space they can move throughout, kind of like a regular enclosure. And they would control how much heat there is, how much light there is in 4 different test groups.
Right. So, and yet of the study, you state that small iguanas reacted more strongly to temperature and preferred higher temperature than large iguanas, right? So it explained that like the mechanism was likely metabolic rate, which demonstrate how stages of life and size may influence temperature. So the question is, that is my opinion, is that the bigger means the older the age is to animals, which we know is a misconception as a psychology student, right?
Yeah.
So, but the younger a person is, the more sensitive it is in comparison to adults, like taste buds.
Yeah.
So, do you believe it is the same to iguanas?
So here's the thing. Now, at different stages of life, not light, you'll have different sensitivities to heat. Do you need to be warmer? Do you need to be colder? But in generally, your necessary amounts kind of abide by the law of thermodynamics. Like there are people like make theories about like over evolution as people and organisms get larger, they're going to have a lower natural body temperature. That's not something they applied in this article, in this research paper, but I feel like it is something that is applicable. And it could be researched further. I actually didn't see any other research that was done on specifically size or stage of life, except for this one, which is interesting and maybe brings in a factor of, is it less valuable or is it just something that's been ignored when it shouldn't have been?
Right. So let's go to the interaction between temperature and behavior.
Yeah.
So you have looked into temperature inductive reproductive behavior in red-sided agata snakes. Yeah. So what have you found there, and why you have mentioned that temperature during the hibernation period of the red-sided agata snake plays a large role in affecting the reproductive behavior of the red-sided agata snake post-emergence?
So this one was really cool. I looked into specifically the red-sided garter snake.
Yeah.
I learned about it like several years ago. I was like, that's a really cool thing. And then as I was doing my research, I was like, okay, I should investigate that. I've seen this before. So the general gist of that article, and there were multiple studies on it actually, is that temperature in hibernation and after hibernation affect reproductive behaviors. So one article, the larger one, I believe the main finding was that if you were to control the hibernation conditions to be lower temperature or higher temperature, it affects a lot of their inner systems, melatonin rhythms, corticosteroid rhythms, all things like that. And then after they emerge, when they're introduced to spring-like conditions, based on their group, they would exhibit higher or lesser reproductive behavior in specifically the first 10 days. After 10 days, they all adjusted to about the same rate. And then eventually they tapered back down to lower reproductive behaviors.
So what does that mean?
What does that mean?
Yeah.
So basically that means that they actually used a scale for reproductive behavior. They had a scale from 0 to 5 based on the behaviors they exhibited. So for 0, that is, they don't interact. The male snakes do not interact with female snakes. Also, I want to point out, a lot of it was centered around male snake behavior. They did not focus on female snake behavior, mainly because they're the one who enact the actions. The scale from 0 to 5, 5 being they successfully reproduced. The snakes copulated.
Yeah. So what is the finding of that?
So the finding, I believe, was that the snakes that were introduced to the warmer hibernation states, which was around 15 degrees Celsius, rather than standard 10 or the lower 5, were slower to reproduce. They did not reach their peak as fast, and actually they didn't. They had believe it was actually a lower peak that extended over a longer period of time, and it actually was explicit. You could see there were 2 lines with 2 different curves, with this one being actually delayed by a solid 3 to 4 days.
Yeah. So I like to bring in one small thing in is tolerance. So we know that humans, we have drug tolerance, which if we keep consuming alcohol throughout the months of years, we'll build up tolerance. So for example, now we drink 2 bottles, we'll get drunk, and if we drink 2 bottles every single day, in a month, maybe we need to drink 3 bottles in order to get drunk. So for the red-sided garter snake, do you think that throughout tolerance, by that research, for example, 10 degrees Celsius, right? And you can see the red garter snakes have a slower reaction time. So throughout timing, do you think that when a tolerance for the snake is up, the reaction time for the snake is faster in the same temperature?
So I'm curious. I just want to inquire about that. You mean are you saying if they did the same experiment multiple times that they could get used to it? So I would argue no. Just based on what I saw, they did not have any research design based around them repeating the same experiment. However, I don't think this is something that can be overridden by experience. However, I believe if they were to be placed, there was actually one sub-article I read about generally different snakes across different regions. They would exhibit different levels of activity and melatonin rhythms during their hibernation period. And that's because they had different climates. I would believe that over time, if a snake were exposed to the same, or a different hibernation state than they previously were in, say these snakes were placed in a hibernation of 15 degrees Celsius for several, hundreds of years. I believe it can be an evolved thing. However, I don't think it's something that they can develop in their lifetime. Maybe a little, but that's only speculation.
So you have also mentioned that in another study of the red-sided garter snake, behavior has been seen to be affected by temperature post-emergence. So talk about that.
Okay, that was the cool one. So the previous one I mentioned was one that had some pretty cool empirical findings. However, this one was interesting because there was mimicry behavior. So there were some ancient terms like transgender snakes and stuff like that. That was really funny. It would be now there was no actual transgender snakes, so to speak, by any terms like that. However, they basically the male snakes, that were slow to emerge, during the spring season, they were evolutionarily less fit. They were less fit to survive, to copulate, to reproduce, because they're colder, they're slower, and they've missed a large period of time. So what they did was those snakes that emerged late and were cold would mimic female hormones to attract other male snakes.
Mimic females' hormones?
Yes, they do.
What?
It's awesome. It's awesome. It's very, very cool.
That is so interesting. Well, I'm sorry to break you there, but
No,
please continue.
You're good. So they would mimic the female hormones, and they would attract the other male snakes to basically dogpile on them, and they would absorb their heat. And then the moment they were done, when they were warmed up and ready to mingle, okay, they just slither on out, and they just leave all the other snakes kind of blue balls.
Wow.
Yeah,
that is so interesting. Yeah. So back to just now, you have mentioned of melatonin. So let's talk about that topic with another animal.
Okay.
So the role of melatonin in thermoregulation in Nocturnal African House Snakes.
Yes.
Right. So what is melatonin and what is thermoregulation?
Okay. So just start off, melatonin. Secondary hormone when it comes to sleep cycles. We have adenosine, that's the one that of course makes you physically tired. Melatonin is more of a daytime, nighttime cue. In darkness, you'll produce more of it. In light, you'll produce less. Pretty straightforward with how the optical nerves work. But basically, that's what melatonin does. As it regards the African house snake, though, that is a more interesting topic because this is actually a counter argument for many of my other, not a counter argument, sorry. It goes against some of my main findings on how heat and light, mixed with some factors of circadian rhythm, would affect their behavior. So what happens with the African house snake is that they are not affected by melatonin when it comes to their regulation of heat. So this kind of defies my argument because the argument assumes that melatonin, something that's affected by light, is a light-affected hormone, would therefore make heat-seeking behaviors change. But it didn't. That was one strange thing about that article.
So why do you think is that so?
So this is actually a case where it does make sense.
Yeah.
The African house snake, it's nocturnal. Therefore, it is staying awake and aware during the night and not during the day.
Yeah.
As a result, light really doesn't serve much purpose to them when it comes to heat-seeking behaviors.
Oh, is it because they're like a night animal?
Yeah. Because since they're awake during the night, they don't really need to know where heat is based on light cues because the light cues don't help them find heat.
Oh, wow. That is so weird, but...
Yeah.
Yeah, because for us, like, if we just close our eyes and rest for like 10 seconds, melatonin will just start producing from our pineal gland. Yeah. But for them, they're in a dark environment, but they just don't produce like a melatonin. Nope. That is so crazy.
And here's the thing, they actually do produce. That's the interesting thing. Okay. Their pineal gland is still reactive to light. It is a light-sensitive organ in them still. However, they don't exhibit behavior change because of it.
So does that mean at night they produce serotonin instead of melatonin?
No. They'll still produce it alongside if they're exposed to light, which they normally are not because they're going to be sleeping during that time. They still have a reactive pineal gland. It's something that hasn't evolved out. There's another mechanism latent within the Nocturnal African house snake that basically overrides their need to modulate their temperature in response to light, or to modulate whether their resting patterns in accordance to light.
So it's some sort like caffeine. So we take caffeine, it'll just like stop us from sleeping, because of like the caffeine will just what is that, to break the what is that term, like we just break the melatonin cycle.
So that's the thing. Caffeine, to my knowledge, I learned this in sleep psychology, class I just took last semester. Where caffeine will fill in the same spots as adenosine, which is the primary sleep hormone. So melatonin works to inform the body what time it is generally, whether it is nighttime, daytime, should you be asleep. Adenosine says go to sleep. Adenosine says you are awake, because it builds up during your waking hours and then it falls away during your sleeping hours. So caffeine basically fulfills that problem.
Yeah, so it's like the normal circadian rhythm cycle is when it's connected to the adenosine level. So most likely when adenosine is in the peak, is usually at 11 p.m. if I'm not mistaken.
Precisely.
Yeah, so like that time it's gonna be like it'll just ask you to go sleep, but caffeine would just like pull you away.
Yep.
So it's some sort like back to the Nocturnal African house snake, which is like the pineal gland with that mechanism will overlap and prevent that snake to sleep, right? Wow. Wow, that is insane.
Yeah.
Yeah, so let's go to the interaction between light and behavior. So you have picked the seasonal variation in circadian rhythm of like ruined lizard. Before we go deeply into that, what is circadian rhythm?
Yep. So circadian rhythm, as mentioned a little bit before, that is pretty much the internal clock. That is the body clock. It's affected by multitudinous things. However, one of the largely relevant things to how we view it is melatonin. I mentioned corticosterone rhythm. They're all a lot of parallels, but basically it's a rhythm that allows you to go about your daily responses around a 24 to 25-hour cycle. Some animals will actually have a circadian rhythm that's like around 27, 28, some around 20. But generally it's centralized around 24 hours because that's how long the day is. Right. That's how long your displacement of daily events should occur. It's affected by a ton of different things. Melatonin I already mentioned, but something for us humans is social Zeitgebers. You will in the morning drinking a cup of coffee. That's what a lot of people do throughout the day. But besides the actual like physiological responses from the caffeine, you drinking that cup of coffee informs you that it is morning. You interacting with a certain coworker as you enter work. That's another social Zeitgeber. Right. But circadian rhythm encompasses a lot that happens around a 24-hour rhythm.
Yeah, so back to the main topic is what studies conducted and what have you found in the lizard?
So, okay, the ruined lizard, as I can recall, they had a study that documented their behavior in the fall, the summer, and the spring.
Right.
They didn't do the winter because they're hibernating. But the ruined lizard exhibited some unique patterns and traits in their melatonin specifically, as well as just the way it worked in darkness and in light. Right. So, interesting thing about the ruined lizard. So, the ruined lizard exhibits strangely a selective endogenous circadian rhythm. Now, those are some fancy words, okay? Right. But the reason why I say endogenous means that circadian rhythm is running throughout the night or throughout total darkness, which is another setting. They had the spring, summer, fall, and total darkness. That was their last category. But you would see that the ruined lizard would not carry over any of their rhythms in total darkness from the spring and fall conditions of temperature and light. However, in the summer-like conditions, they did, which I found incredibly bizarre, and I even had to draw some of my own conclusions from that.
Yeah. So you also state something with melatonin in the same area of that. Like, can you talk more?
So melatonin, same like time of day.
Yeah.
So basically, what happens is that in the different light-dark cycles, they would have a certain peak of melatonin at a certain time. Typically, that would be right before right when the dark hours of the day started. It would peak a few hours later, and then it would slowly go down throughout the rest of the day. That would occur for all three conditions. Specifically, though, strangely, in spring, that peak was like 4 times higher.
Wow.
Which they drew some conclusions about the fact that there were some different mechanisms for it. The way I viewed it was that it was possibly a factor of hibernation. And that
is it a process to hibernation? That's why it spikes up.
Possibly. It would be after the winter season. Going into spring, I'm assuming that would cause melatonin and other principal hormones, part of circadian rhythm, to spike. Therefore, informing the ruined lizard that they're no longer hibernating. They need to then be on the schedule.
Oh, it means they're ending the hibernation. They need to get rid of all the stuff. So all the hormones need to get back to like normal. In order to get used to that, they need to like spike up all the hormones level and slowly to get back into that into their normal daily life. That's why in the spring it shoot up for 4%.
That's one possibility.
Oh wow! So let's talk about the next topic, which is circadian rhythm involvement in temperature selection and light entertainment. So what have you found in the circadian rhythm of temperature selection in Tokegako?
Tokay gecko.
Taco gecko.
So the tokay gecko, really cool lizard. Love that guy.
Yeah.
I would actually want to have one as a pet.
I mean, you're a lizard guy. So
I'm a lizard guy.
You're a lizard guy.
Listen, I'm gonna be honest. You'll see one of the studies later, which I'm assuming we'll get to. But I'm a big lizard guy. I have one at home. I got a bearded dragon. Okay.
Oh, wait, what lizard is that?
Bearded dragon.
Bearded dragon.
Yeah,
Wow.
he's very cool. He's very cool.
Why didn't you write about bearded dragon in your paper?
Well, that's because I like him. He's my guy. Also,
Right.
very, very fascinating properties of the bearded dragon. But for now, the tokay
let's
gecko.
talk about a paper.
Let's talk about the current part. So the tokay gecko. So this is another nocturnal animal.
Right.
Okay. So the interesting thing here is the tokay gecko did exhibit temperature selection, which was influenced by melatonin and melatonin rhythms. Actually, correction, not melatonin rhythms. They didn't actually measure melatonin. However, they did measure light exposure and entrained rhythms. Right. So an entrained rhythm is when you expose an animal to a certain day, dark and light period over a period of time, and then you expose them to total darkness. So the idea there is that they would exhibit similar behaviors during those previous light and dark periods when they go into total darkness. So with the tokay gecko is that when they were put into total darkness after 2 weeks of exposure to a light and dark period, they had a little bit of a buffer for one day where they didn't seek any heat, and then right after that they were seeking heat during the same light hours of the day as previous. And what's interesting about this is this actually defies the previous thought that we had with the African house snake, which can bring up a few theories. One of them being that the tokay gecko didn't evolve, so to speak, to ignore light rhythms or maybe even melatonin as the African house snake did, or there's a mechanism that we cannot see based on the studies. One of the errors, which I'll touch upon later, is with some of these studies, is that a lot of them are far apart in time, and they don't look for multiple reptiles. They pretty much will only center in on a single reptile and their properties, and then producing a design around that, which makes sense. However, at the same time, you won't have like findings that can be dispersed across multiple different reptiles, multiple different exotherms, with the same recordings that are made, and therefore comparisons can be a little bit tricky.
Wow. Oh, that is crazy. 2 weeks without light.
Yeah.
And second day you just give them light and it'll be reacting like normal.
Yeah.
Holy shit, that is so crazy. Like if that is inhuman, we're like, oh my gosh, like God is coming. Like there's sunlight. Because we all know that.
Yeah, I can imagine from the reptile's perspective, we kind of play God a little bit when it comes to any study on animals. But
yeah, because when you look at us, in order to just like spike our cortisol and adrenal in like a shot, is sunlight. We know that, like early morning sunlight, like get some sunlight in our body, that was like just spike our cortisol and adrenal level on that time. And for 2 weeks without that, we're just get into depression. And when we get back to sunlight, like we start to appreciate more. But when we look at this, like what gecko again? The tokay gecko, it's just like normal. That is insane. Oh my gosh, yeah, you're getting me hyped up.
Yeah, I honestly, I also like the way you like talk about it. Like all of our actions are kind of just influenced by a bunch of chemicals that are going on inside of our bodies. Yeah. And we, if you think about it from like, say, the perspective of this was happening to us, we also would be able to do pretty much the same thing that the tokay gecko did. But how much more advanced does that make us than them? Because we would be doing the same things. We would be abiding by our same. We also have an endogenous circadian rhythm, and it is demonstrated that they have that too. That's a shared property we have, and can be even experimented on in the same way.
Yeah, that's just insane. Right. So the cyclic color change in the behavior in bearded dragon, which is your favorite animal, under different light conditions. So why is the bearded dragon known for, and what demonstration of the study that scientists have conducted with this animal?
Okay, so bearded dragons. So those are my guys. Okay.
Of course.
So
That's why it's in the last.
This was the very first paper I found when I was looking for these topics, generating a thought, hypothesis, a thesis, anything. I searched for bearded dragons. I looked through a bunch of completely useless papers, and then I found this one. Not to say all experiments done on bearded dragons are useless, but this one was very, very fascinating.
Right.
So bearded dragons, like many different various reptiles, okay, will have the ability to modulate their skin pigmentation.
Right.
So bearded dragons in particular, they can make themselves darker and lighter. You can see a bunch of pictures online. They'll have like a large variation of color from like brown to like yellow and orange. But a lot of the pictures you also see they're like really dull gray or black because they can change how vibrant they are, how dull they are. In the purpose of this is to absorb more or less light. Yeah. They change the reflectance of their skin in order to become warmer or colder.
Wait, so what type of animal? So they're cold-blooded animal?
They are. All of these animals are cold-blooded. Every single one. Yeah. That's the purpose of this paper. Yeah. But the thing about the bearded dragon that's so special is that they will deliberately change their skin pigmentation to become warmer or colder, while a lot of the ones we mentioned, the tokay gecko, I won't point out one of those the operations of the experiment. The way they provided heat in a dark setting was just a heat rock. Right. It was a artificial rock. They put some heat under it, and a lot of those behaviors for making themselves warmer or colder was to move. You had to go somewhere. Yeah. The thing that makes the bearded dragon so special and unique is they don't actually move that much. Yeah. They'll go to a spot that has exposure to light, has exposure to heat, and they just change their color to be according to what they want, what they need.
What? Wait, what?
Yeah. So a lot of what I talk about is behavior. Okay. Yeah. This skin pigmentation change, it is a behavior. It is an action they have. A lot of it is just reactive to their environment, but at the same time, they behave this way in order to reach a state they want. The state they want is to be a certain amount of warmth. That's it. That's what they want. That's what they desire. And I know desire very anthropomorphic terms, anthropocentric, but no worries about that. Okay.
Yeah. Well, so let's. That's a whole paper you have shared. I really appreciate that. So let's see what you have concluded and what is your discussion of that paper. So what do you have concluded? What is the findings and what future research should scientists look for?
Okay, so from what I conclude about this is that the general thought and purpose of the paper was fulfilled. Yep. It is that reptiles, specifically just in general exotherms, we can attribute to exotherms, that they have a response, they have a reaction to heat and light. Yeah. And a thing of note is also that a lot of these reptiles, not all of them, they were tested for exhibiting a circadian rhythm, whether it's endogenous or it's in response specifically to heat and light. And a lot of these are like completely reactive to one another. If you change heat, you change light, you change something in their setting that can affect their circadian rhythm. They all are intertwined, and it's done because they are cold-blooded. That is the root of all this. They're cold-blooded animals. They need heat. If they don't get heat, they don't survive. Now, us as humans, we also do need temperature. That's one of the core things for survival. Yep. All non-exothermic animals, endothermic animals, they also need heat. However, they produce it themselves, and as a result, they can behave differently than, say, an exotherm would be, who are completely reliant on their environment for this temperature change.
Yeah. So what is the future research that we could look into for all these?
So I touched upon this a little bit earlier with the tokay gecko as it compares to the African house snake. The issue we have, I feel like, that can be like resolved with a lot of these papers is just doing better research. Now, I think the research was great. Okay, it was fantastic. They did good work. A lot of their operations were well. However, some of them are not the most comparable. You can compare the tokay gecko and the African house snake through the fact that they're both nocturnal and that they react differently. However, one, you're only measuring the exposure of the light, and the other one, you're documenting melatonin. And they were injecting external melatonin. They weren't just using light to influence that.
Yeah, I 100% agree with you. Like, even my paper when I wrote my cognitive psychology paper, what is going on is that I was trying to find every single behavior when an animal is sleeping,
Mhm.
and I was trying to like find their brainwave and how they're gonna react when there's prey going to them. And what I found out is not enough research. It's either like one have one of it and the other don't, and it's so hard for me to compare every single one of them. And
That's the thing.
it is annoying.
That's the thing with research. It is.
Yeah.
It's not really just a pursuit of knowledge. It's
Yeah.
a purpose. Now, a lot of the studies that I mentioned, I'm pretty sure almost every single one was descriptive.
Yeah.
It wasn't really aiming to create a medicine or to create something to compare to human psychology.
Yeah.
While it could serve that purpose and further developing theories and thoughts on the matter can, a lot of them are just searching for a specific thing,
Right.
and they don't really go further than that. I think a larger pursuit of knowledge on all facets of it would be awesome. It would be incredible.
Right.
But that's pretty much the only thing we can hope for. And honestly, just more research on the subject matters about heat, light, circadian rhythm, how it can influence behavior
Yeah.
would be interesting and very cool to see in the field.
Right. So final remarks. What's your final remarks for this?
Honestly, thank you for having me. I think it was very cool to talk about my paper.
Yeah.
I'm gonna be honest, I haven't really thought about this paper since I like made it last semester.
Right.
And actually, like talking about it out loud, I feel like it was good to voice all the different like parts, specifically in the important parts of the paper that I wanted to voice.
Yeah. I mean, your paper is not published, but like this is like a small publication in another way.
Yeah,
so...
no, I'm glad to do it. Glad to do it.
Yeah, sure. Thank you so much.